So my name is Iulian Dragos. I work for TypeSafe. I've been working at TypeSafe since 2011, basically from the beginning, and mostly on the Scala IDE for Eclipse. I've done some other work, and before that I worked on the Scala compiler during my PhD. And today I want to talk a bit about the history of the IDE, and then in the second part, which I think is probably a little bit more interesting, about a couple of new features that just arrived in the 4.0 release. I think that was sometime in December last year. And to show off, because I think one of the most important features in 4.0 is an API for developers, I'm going to show you how you can code an SBT file editor with this API. So basically, what the API gives you is core compiler services and components you can use to build your own Scala-like DSL and get the IDE services for that language. And I chose SBT because I thought this is a pretty complicated example, so you have to do a couple of translations. It's not plain Scala, and also the class path is different, so it's a little bit more involved. So that part had very cool demos. Well, you'll have just to imagine, and I have a couple of screenshots for that. So where it all started, I didn't really know exactly how to show you the bare bones Scala IDE we had in 2011, so I just took a screenshot of the preference window, and I actually managed to find a very early version of the Eclipse plugin for Scala, and it had basically four things: syntax highlighting, formatter, compiler, and some templates, which are basically just plain Eclipse templates, nothing more exciting than that. So who wrote this plugin? These were early days, probably around 2009, 2010. TypeSafe didn't even exist yet, and I just wanted to mention two names here. So Sean McDermott, he was a PhD in Martin's lab at EPFL, and Miles Sabin. And probably you know Miles more for his work on shapeless and type-level programming and advanced type wizardry, but back in the day he was a maintainer of the Eclipse plugin for Scala. And I think what these people managed to get, besides a functional, very limited but still functional Eclipse plugin, was to build a community. So we started to have volunteers, people who were very enthusiastic about Scala, just contributing to the Eclipse plugin. So the formatter was contributed by Matt Russell, and I'm really sorry, I haven't seen him in a while, but he contributed a ton of really cool features. So, and Mirko Stoker on the refactoring side. So there's a community sort of trying to do something for Eclipse and Scala. I would describe this part of history as wrestling with the Scala compiler. So the Scala compiler, we all know that it's slow. 4 years ago, those are the days of Scala 2.8. It might feel a little bit faster, but still, as you're typing, you can't really run the compiler in the background and not feel it. So their efforts focused on making it incremental. Especially Sean, he was a researcher. He wanted to say, well, if your changes are local and affect just a small subtree, let's try to recompute the minimum you can, so you still get up-to-date results. Another problem was there was a threading model that was totally undefined and unclear. So even though Eclipse sometimes feels like it's doing everything on the UI thread, it doesn't. It has lots of threads for the builder, for the reconciliation, for a lot of things. But the Scala compiler is single-threaded. So all of these things somehow led to lockups and a lot of pain trying to debug it. When TypeSafe was formed in 2011, I think at that time Eclipse was really the top dog in the IDE world. Maybe that's changed along the years, and probably today it doesn't dominate the market as much as it did in the past. But what TypeSafe realized was that, well, we need to increase adoption, and Eclipse is a key part in that. So for the first release let's say after TypeSafe was formed, the really important bit was the presentation compiler. And I don't know how many of you have heard of the presentation compiler. Yeah, so that's quite a number of people actually. So the presentation compiler was backported to 2.8.2, I think, the first release that had it, and it's basically cleaned up a lot about the threading issues. So the model is very simple. It's single-threaded and confined. It's a little bit like Swing. So if you want to run something that accesses internal data structures in the compiler, it has to be done in its own thread. So you're just posting a runnable, or of course a Lambda in Scala. And this presentation compiler got to be quite successful. So besides Scala IDE, and Sime, which is an Emacs mode for Scala, the play templates, and I think Sublime also is based on that. And I'm pretty sure there's a web-based interpreter or worksheet that does the same thing. One notable exception is IntelliJ. So the IntelliJ crowd and the people there, they decided to build their own type checker. And it made a lot of sense because of all the infrastructure that IntelliJ gives you for building language IDEs, as opposed to Eclipse, which is pretty limited in that regard. So the presentation compiler, I think that the idea there was, well, we want something precise. So we want to really use the type checker in the Scala compiler, but we want to make it fast, or at least appear fast. So this goal drove all the other features in the presentation compiler. So it's asynchronous, meaning that as you're typing, type checking happens in the background, in its own thread. But obviously, if you needed to do something like completions at some point while you're typing, you need to interrupt this thread and ask for a service. Give me completions for this position. And completions are actually quite a hard problem to solve because you need precise type checking. You need to know the exact type of what's to the left of the dot, so you really need a compiler that's capable. You might have implicits that need to be resolved, and they bring on more methods that decorate your type. So we really need a precise compiler that is interruptible, and then in order to respond to these requests quickly, it's also targeted. And that really means you always start with the position. If you want something at a given position in your source code, what's the minimum amount of context you need? So it would type check only the path from the top of the file, skipping a lot of methods if they didn't need to be type checked, and only answer to the query in that position. So I think this was a great move forward because it provided a sort of level playing field for all IDEs. In the end, it's Emacs and Scala IDE currently that really use this to the full extent. And here I wanted to show you actually the IDE in action. I found the 5th beta version that we had. I couldn't find the first one, unfortunately, from 1st of June 2011. It actually works. So unfortunately, this is not my laptop. I just copied the presentation, and I'll have to skip that. Let's move on to the first IDE release. So the first IDE release had version 2.0, which is kind of funny. But let's not talk about versioning. Let's just say that we needed a smooth upgrade path, and all the other milestones were 1 dot something, so we needed to make Eclipse understand this is actually a newer version. So to get there, we went through 12 beta releases. I'm actually quite happy that we had a release almost every month in the year of 2011. The main features, the presentation compiler and incremental builder built on SBT. So in terms of features, it was pretty limited. Hyperlinking, completions, report error as you type. But what I want to mention here is the fact that we used SBT for building behind the scenes by embedding SBT. So we really took the parts of SBT that look at compiling and dependencies between projects and source files and put it inside Eclipse. And this was before Zinc and the incremental compiler. How many have you heard of the incremental compiler in SBT? Yeah, so that's a component that now was extracted out of SBT to power Maven, or I think Gradle is not yet using it, but it's basically a reusable component of SBT that only builds and trying to limit the number of source files it rebuilds every time. So we sort of did this before, and then the SBT team finally decided that this is the right thing to do, so then they created an API. So we fought quite a lot with SBT, getting it to work in this scenario. But as a consequence, then Maven people also got a nice incremental compiler. What I want to mention here is that the Scala version that your project can use was directly linked to the version that is shipped with Eclipse. So this kind of tight connection was determined by the way the presentation compiler works. So and no binary compatibility between major versions meant we had to release actually 3 versions of the first plugin for 2.8, 2.9, and 2.10. So that's kind of annoying, but it stayed with us for a while. So once this release was out, we said, well, people are actually asking for more features, and let's try to build now on this more features. So one way to do that is to just add them into the plugin one after the other, and then make a large release. But the alternative was let's make them additional plugins. So we ended up with an ecosystem, we started calling it, of additional plugins. So for the second release of the Scala IDE, which is number 3.0, we had a ton of new features and a couple of new plugins. So I'm just going to go through some of them, and I'm going to highlight maybe two. Besides semantic highlighting, which was contributed by the community, and Mirko did a lot of work to make that really fast. We had implicit highlighting, a Scala-aware debugger, and the Scala-aware debugger, I don't know if you've used it, but a Java debugger would step into every getter. So every val is a method, in fact. So you cannot really step into without doing a round trip, useless round trip through the getter, which just returns the field. So we tried in the debugger to encapsulate a lot of the knowledge we have on how Scala is compiled down to bytecode, and try to remove some of these annoying little quirks. Yeah, JUnit Test Finder was some work that we did for the IDE, but what was really, I think, the major feature in 3.0 was the Scala worksheet. So the Scala worksheet, I think probably most of us have used it, was the first plugin built on top of the core IDE. So this is not part of a monolithic IDE, it has its own release cycle. So we needed that because the Coursera course, so back in the day there was a first functional programming in Scala Coursera course, and Martin really wanted to have this feature to teach with. So we had to have a ton of releases that were basically maybe not every week, but quite often internally first, and they were not tied to the rest of to the core of the IDE. So that was not the only one, though. We had the Scala test plugin, and Bill Venners and Chi Sang did a wonderful job at building this Scala test plugin and also maintaining it. So whenever there was a bug or a new release, they would just rebuild and have, from day zero, a Scala test plugin. As we went forward, Play 2 was another plugin that we added on top of the 3.0 series of the core IDE. So Play 2 templates are quite rich. So you have HTML in there, but you can also have Scala snippets. So we wanted to give you a nice way of editing these templates with errors, with all the type safety that you'd expect from Scala. Also completions, all the semantic actions you have in the Scala editor. So I think we got pretty far there, and a lot of work went into that, and Jed is here, so I'm very happy he could join us. He was an intern in the summer of 2013, I think, right? And he managed to push Play in the right direction, basically reusing all the HTML editor infrastructure in Eclipse. So I think it's really good now. A couple of other plugins, I'm not going to go too much into it, so let's skip forward and talk about the latest release, which was codenamed Lithium, but it's really 4.0 or the third release. So in the picture there you have the highest peak in the Bernese Alps in Switzerland. It's called Finsteraarhorn, and basically for me, I think it is really a peak what we managed to do for a 4.0 release. And I hope I'll convince you by just going through a couple of features next. Here's the preference page for 4.0, and just focus on the left column. So the number of features really it's much larger. So let's see what are those. The first one is really a performance improvement, and I call it quiescence type checking, but it really means for every keystroke, at least in the previous releases, we would start a type checking round in the background. And this doesn't affect you because it's a different thread, but type checking means parsing, means creating an AST, a lot of objects that are thrown away the moment you type another character, because now the source is different. So that led to really huge spikes in GC times. So actually, even though it's a different thread, you might still feel on the UI thread as you type some lag, because the GC has to kick in, and even a concurrent garbage collector still has a very short period when it has to stop the thread. Some quick fixes, and I think my favorite one was implement abstract member. But I think the real, this is probably one of the biggest changes we had in 4.0, is that now you can have in the same workspace projects that work with Scala 2.10 or 2.11. So we managed to decouple the Scala version in your own project from the one that ships with the IDE. So for me, this was a huge time saver as a maintainer, but I imagine it's even more for users, because you don't need to switch workspace, keep several installations and so on. And it may sound easy, but okay, we'll go through, and it was actually again a collaboration with other teams, because the solution we found, I think, is pretty interesting. And the last one is basically the focus of the SBT file editor code exercise I wanted to do together with you. It's a stable API for plugins. So all these plugins I showed you, they just went into the code and grabbed what they needed to use. So every time we released the IDE, we asked them to re-release, and maybe we broke them, maybe we didn't really know. And looking back, engineering-wise, it might sound like a really bad decision to do that and not have the API, but at the same time, I think we provided, well, first of all, more value for users by allowing these plugins to start. And second, we could design an API by having 3 or 4 use cases already, by knowing what people have actually used and designing around those needs. Yeah, quiescence type checking. This is really a screenshot from, I think it's Visual VM by typing in an editor. So that's how the heap goes up and down on a previous version. I don't want to insist too much. It's there. There is a change. For multiple version support, what we had to do was still, let's say we ship the IDE with a version of the Scala compiler, 2.11 in our case. But let's make the compiler understand that there is a source level, so there's a new source level flag, and the compiler just falls back into 2.10 compatibility mode, where it actually understands the class path of your project as being 2.10. So your dependencies are cross-compiled with 2.10. They are 2.10 dependencies. The Scala library is again 2.10. So and it can actually suppress error messages if, let's say that sometimes in 2.11 we fix some bug and then something is illegal now. If you put it in a 2.10 compatibility mode, it will not issue that error. So it tries to behave like a 2.10 compiler. When you build though, it's going to be really a 2.10 compiler. So we ship 2 compilers with Eclipse. If you're needing to build, you can, it will just use 2.10. And that's actually extremely important if you're using macros, or if you're using a compiler plugin, because the compiler plugin is very tightly coupled naturally to the compiler. And a lot of people use compiler plugins for macros. So there's Macro Paradise, which I found out while working on this feature that it's quite ubiquitous. A lot of people use it. So this is the solution we found. I think it works fairly well. The consequence is that for 2.10 projects, you will not get macro expansion as you're typing, but that shouldn't affect much. The type checker still understands what's happening. All right, so the Scala IDE API. This, as I already mentioned, was a pretty large effort because we practically took every class in the core and try to clean it up, document it if it was used outside. If it not, we put it in an internal package and then go through all the plugins that existed and update them. And we even issued pull requests to plugins maintained by other people because we didn't want to lose them, obviously. So what kind of APIs we offered? I think the most important one is the compiler service. And whenever you write a tool like an IDE, you probably want it to be smart enough to understand the Scala code, and for that you need type checking. But we also went into some of the UI sort of features, and we provide components for error reporting, auto edits, syntax highlighting, and all of those things, completion hovers, and so on. And the last one that I'm not talking about today, I think it's actually quite important and it's very easy to use. It's save actions. Right now there are maybe 4 save actions, so when you save, what should happen to your editor? Some people want to reformat everything, others want to organize imports, or remove white space at the end of every line. So these sort of things. Those can also be easily extended now. Okay, so this was the part where I was supposed to do live coding. I'm just going to describe a little bit what's going to happen. So our task is to get SBT files, which are pretty much, well, they're small files that have Scala syntax, but not precisely Scala. So how do we get an SBT editor that behaves in a sane way? So like a Scala editor, errors, hovers, syntax highlighting. And for that we need a small detour just to tell you a little bit how Eclipse editors work. There's a lot of documentation out there, so I'm not going to insist too much, but there's basically 2 components that you'd need to write, or two classes that you need to extend. One is called the text editor, and in principle a text editor is, unless you really want to customize something really deeply, it's probably a pretty small class you have to do. But this guy is configured by something called source configuration, which is just a class having maybe 8 or 10 factory methods. And each factory method returns an instantiation of a given concern. So completion is one, hovers are another one, what do you do when you want to show errors is a third one, and so on. So what we're going to do basically is going to implement this source configuration by giving components that handle Scala DSLs. Partitions, I'm going to mention them because if you look at the code on GitHub, you'll stumble upon them. Partitions are a way to define regions in your document that carry sort of specific services. So completions in Scala code are probably different from completions in Java doc or in Scala doc, or in strings. And I think these are the main three cases. Oh no, there's XML as well. So in XML you probably want a different type of completion than you want in or different implementation. So partitions are basically a way to refine these services in the same document. So the first step is to add just syntax highlighting. And as I mentioned, there's a factory method for every one of those, and this one is called getPresentationReconciler. And what we have to do there is to get some sort of a token scanner. So a token scanner is roughly a regular expression that goes through your source code and matches and gives you basically regions that should be highlighted in a certain style. But with the current API, or I should say with the 4.1 API, you don't really need to do anything. If your configuration class extends default Scala editor configuration, this comes for free. So it would look something like this. Comments are green, strings are blue, and so on. And all of this is actually configurable from the Scala syntax highlighting configuration preference page. It's all picked up from there. So this is really the easy part, because if you're only looking at tokens and not really at syntax, the defaults work just fine. But if you have a more complicated or a sort of slightly different DSL than Scala, you need to tell Scala IDE or the core components how to understand it. And you just need to do two things: a mapping from your DSL to Scala code, valid Scala code, and then you also need a mapping between positions. So the core components work in terms of Scala source and mapping between positions original and Scala. So it needs to go both ways. So let's have an example. This is a very simple SBT file, but the Scala compiler, if it tries to parse this, it will say something like expected top level class or object or something like that. So what we would do is we'll provide a function that adds some sort of a prelude, a number of imports, the default imports in SBT files, and just some container and methods and closing them. We just put them around. And this will make the IDEs not complain anymore. So it will just type check this, and because the imports are there, it will resolve all of these names. This is the easy part. Let's go now to positions. Since the compiler gives you back tokens that need to be highlighted, these are positioned in terms of your Scala source. So that means everything is shifted to the right because I added these imports. I need to provide a mapping to go back, and the same thing happens with errors. If I have an error at a given position, I need to be able to translate it back. The other direction is useful for hovers or for completions, because in that case I'm starting with a position in my actual DSL, but I need to map it to the source code so the compiler can tell me, okay, I found these completions here, so there you go. So how do you do that? There's one important abstraction in the core IDE, and that is called an interactive compilation unit. A compilation unit is really a fancy name to say a source file. Because I think that in compiler somehow we try to abstract over the fact that we're working with files, but I think everyone in the end uses a file. So this compilation unit gives access to the current contents, which in our case it's backed up by an editor, and also it gives access to the compiler and the project. And the one method that it's really down there, I think it's I should have put that first, I think, a source map. And this is what we'll need to implement. So the implementation that we'd need to write in our case is something along these lines. So I define a source, a SBT source info, which, let's forget a bit for a second what the abstract file means. I have an original source. Array of cars are everywhere in Eclipse, and finally also in the Scala compiler. I think that, personally, I think strings are a little bit ineffective or inefficient, so array of car is a little bit faster if you do a lot of reading. And I'm just defining the base imports, a prefix, and it's really quite dumb. I'm just splicing in the original source into these imports and the object that I wanted to have. And the second part is to instruct the rest of the IDE how to map positions. And in my case, it's again it's a very simple transformation. I'm just adding the length of the prefix, and also since I added an extra new line, I put it there as well. And going back to the original position, I'm just subtracting that offset. So roughly, this is what I have to do. Now, if I were to run this on my SBT editor, and if I had now my laptop I could have shown you, something would still go wrong. And I'd get some very weird error messages. So I was a bit surprised when I was writing this talk, because I expected this to be the only thing I have to do. And the explanation is that in the Scala IDE there's a presentation compiler that I already mentioned a few times, which is tied to the project. And the real information it picks up from the project is the class path. But SBT sources are not using the same class path. An SBT file is using the SBT class path, and most likely your SBT jars are not on your project's class path. On top of that, SBT is still on Scala 2.10, so you might be using 2.11 and then you're out of luck. Plus it has tons of macros, so it's a really pretty special compiler that I'd need for SBT, for this editor to work. So at this point I got a little bit nervous working on my slides, because I somehow sensed we'd need this kind of feature in the API, but nobody used it before. So luckily it worked, so I can show you how this can be done. We just need to create a different presentation compiler only for SBT files. And there's a nice abstraction that we actually used throughout the IDE, which is a proxy object for the presentation compiler. And the reason is that the compiler is such an expensive component that if you have like 20 projects in your workspace, eventually you could have 20 compilers, one for each project. But you want to be able to shut them down to save memory if you're not really typing in that thing. So the proxy publishes lifetime events, when the compiler was last used, and for how long, and so on. So there's a thread that shuts it down, and it actually makes the memory consumption much lower. This is another new feature in 4.0, by the way. So memory consumption is really much nicer these days. So I started using that thing, and all I have to do, finally, I was very surprised, this is basically all the code I had, was to create a compiler instance and feed in settings. And settings are just a class from the Scala compiler, where I just filled in the class path value. So I don't know if you can see there, but I just looked at all this, around 20 jars of SBT modules, and I just hard-coded them to go to my IV cache. So it's just for this demo, but it really works. So this creates an additional presentation compiler that knows only about SBT jars and can actually type check that source file. So unfortunately, can't show you, but it does. This is more of for your information, a reconciler. Sometimes you might find this, if you ever want to do this for Scalate or Scalate, I don't know how you pronounce that this is another templating language for HTML with Scala expressions embedded. If you ever want to do that, you might stumble upon a reconciler. And the reconciler well, it's an abstraction that Eclipse calls every 500 milliseconds to update error annotations, basically. So again, if your configuration is going through the default Scala editor configuration, this is already set up for you. And I'm just showing the code because it's all boilerplate. This is something that we wouldn't have to write in this example. It's just the implementation in that default thing. So it's going to call reconcile and update the error annotations. So this is all API calls that exist. What we get is something about, errors. If I hover over the little red cross, I'd get the error back. So this was the hardest part so far, and it actually had one unexpected detour I had to take, and that was the special compiler instance. But in principle, if you have compilation units and source maps, that's practically everything you need to do to write your own Scala DSL with proper editor support. So I didn't mention hovers there. Yeah, this moved a little bit to the right. This is again done for you, and you would get this kind of hovers in SBT. And what I wanted to emphasize is that it actually retrieves Scala doc, another great feature in 4.0. I keep forgetting, there are too many. Scala doc support. So this hover actually goes to list, apply, and brings the Scala doc, even though it's an SBT file. So I think it's pretty well integrated with the rest of the core IDE. So the last feature I mentioned that I wanted to have was completion, and this requires a little bit more work. So for some reason that I still have to dig out, the completion engine that we offer in the API is completely oblivious to source maps. So we'd have to basically call into the component and do some work when the proposals come back manually. So this is the code I had to write. Basically, get completions is the API code. It's right in the middle. That's what comes from the API. But before that, I'm having to set up two positions. One is, and both are mapped through the source map, as the one that I just defined 10 minutes ago. So the mapped region tells you what are the characters, the prefix that user already typed. So if you type dot and a couple of characters, you only want completions that match those characters. So I have to map that region and then the exact position. What I get back is proposals. So every proposal encapsulates a method or a class, and it tells you quite a lot of information, including Scala doc, name of parameters if there are any, and so on, and an insertion point. So that's what I'm doing at the last part there. It's a case class. So I'm just copying it and moving the insertion point back to where it should be. So I get something of this kind in my SBT file. Notice that a couple of things that come there are just classes. So if you really wanted to make this a bit cleaner, you could filter out things that you don't want to see in SBT files, because most of these things would add an import as well. Maybe it doesn't really make sense for SBT files. All right. So far we talked mostly about semantic features, but there's one other pretty neat thing you can do in an editor. Again, complete plain Eclipse API is auto-edit. So there's a number of automatic edits you can do. When you open a quote for a string, you can also close it. When you open a command with a Scala doc command, you can also close it as well. So there's a number of these that we predefined for Scala. We don't add them by default because sometimes, it doesn't make sense if you're inside a play template. Maybe you don't want all the command auto edits to be there. But this would be roughly the code I would have to write. I would just say in what partition. So in Scala docs, I'd like to have the command auto closing and so on. Again, cannot demo this. What I didn't do, and I think it could be quite interesting for a complete editor, is a source formatter, which probably is very easy for SBT files, and hyperlinking. And hyperlinking is a bit problematic because you'd need a way to locate SBT sources. Most of the interesting things there come from SBT itself. I don't think it's a big deal. I think it's fairly easy to do, but I didn't do it for the demo. All right, so to conclude, I think there's a pretty powerful toolkit inside Scala IDE that you can use to build nice, well-behaved editors for Scala DSLs. And Scala T or Scalate comes quite often, it comes up on Twitter, people asking, when are you going to do something about that? And I think that I'm much happier to offer this kind of API and let people use it than to do the work and just tuck it in there. It took me about 4 hours to get this demo working. I think most of those hours went into debugging one stupid mistake in the way the presentation compiler was set up. But I think it's a fairly good, let's say fairly powerful API, and I think it's going to get even better along the way as we understand what people use most. So before I end, I want to give you a glimpse of what's going to happen after this release, so in the future. And I'm very happy to announce that Virtus Lab is going to work with us on Eclipse with TypeSafe. And Virtus Lab is a pretty cool company from Poland. They've done a lot of work on Eclipse plugins, and they contributed already some very good code. For example, the watchdog that shuts down presentation compilers is work that they done. They had Scala compiler, pretty important improvements in memory consumption in the Scala compiler itself, in Scala C. So I'm very happy that they're joining us in this effort. And we plan to have a release in 1 month, roughly, 4.1. And the main new feature there is a debugger with evaluate expression. So when you hit a breakpoint, type an expression, evaluate, see the result. I think that's super exciting. They've done most of the work, and I'm really looking forward to see that. Lastly, all the code is in my GitHub repository. There's even a pull request, so if you want to help push it above, beyond the finish line, especially removing all the hard-coded paths in my Ivy home, you're very welcome. And any contribution you want to make to Eclipse or to Scala IDE is super welcome. And we're very friendly. Join us on Gitter or on our mailing list. Thank you. If there are any questions, I'd be happy to answer them, of course. Yeah? Not so far, and I think it's mainly because we didn't really publicize it well enough. So this is actually the first talk about the API itself. So I'm planning to write some blog entries about it. I hope it will happen. Yeah?
Does the API also support embedded other languages in Scala, for example, SQL?
Yeah. So the question is if you can embed another language like SQL in Scala, and if this API would help you. Is that the question? It's a good question. I think this particular API would not help you with the SQL parts. So probably not. I think it's more the other way around. If you're starting with a language that is not Scala but can be translated to Scala, then this is what will help you. Yeah.
If, for example, I had some source code shown on the web browser and I wanted to propose presentation file services.
Yeah.
Is that something?
Yeah. So if you wanted to, so the question is if I have a web service or a web application, I show source code in there and I'd like behind that to add the presentation compiler services to do some semantic actions. Yes, and I think there's a project that does that. I forgot now the name. The person is called Guillaume Mas. He's at the conference. And he did a REST front end for the presentation compiler. But I don't think that's a lot of code in that REST front end. So you could definitely do that. All you need is a position and the source code, which is an array of cars. And from there on, you get the results. Cool. Yeah.
So a little over a year ago, our team actually switched from using Eclipse to XQT for better and worse. We've had problems with both engineers. But the biggest issue we had with Eclipse at the time was slowness when we were typing and kind of locked out and didn't know what was happening.
Right.
And it seems like there's a lot of effort in improving that.
Yeah. There is. So I think it's much improved. It would be great if you could try the 4.0 release. Actually, another thing we did was to basically, instead of just giving you update sites, we just package a whole Eclipse distribution with everything we think is useful, like Git. And so basically, you just get an executable, you run its Eclipse inside with the Scala plugin, Git, and a ton of other things. So I think if you want to give it a try, it would be great. We put a lot of effort into making typing as fast as possible. So the effort with GC pauses was basically driven by that. I'm not saying there can't be cases. I'm using it every day, so I don't see any pauses. But sometimes the compiler itself can get into some exponential whatever search for implicits, and in that case it consumes a lot of memory. So it could be sometimes the source code itself that drives it, sometimes it's something we do wrong. But I would say 4.0 is way better than 3 in that regard. Cool, all right, thanks again, and I think we can head for lunch.